Alright, hi everyone, welcome to my YouTube channel, CCF Electrons. So like I said, this will be the last one okay, for this semester. Of course there are other things to do, but come on guys, sorry about the fact that we have to stop here for now. So we'll just take this last video and hope this little for this semester helps. Okay, so yeah, this question, we use this question to explain this topic, but the whole concept is just how power flows. Okay, this electromagnetic wave. Okay, talking about electromagnetic wave, the power flow here in the electromagnetic wave. So this is the question: consider a 100 volts per meter uniform plane wave of frequency 300 megahertz traveling in an infinite lossy medium. Okay, having these values. All right. Now conductivity is what? 0. Conductivity is 0. Take note, conductivity is 0. So it will affect the formulas we make use of. Okay, so write complete time domain expression for the field vectors of the forward traveling wave and determine the average power density. Okay, now the solution, let's take data. Okay, so we take our data. This is what we have. All this data is taken from the question. Okay, taken from the question. Now the electric field for forward traveling wave is this. This is the expression for it. This constant cosine of omega t minus beta z. Okay, now the thing is that we need to find beta and plug it here, or substitute that thing here. This guy, we already have it as 100. It's given in the equation. It's given in the equation. We already have it as what? 100. Omega 2 pi f. 2 pi f. 2 times is 600 pi f. So that one is even obvious. But we just need to find this guy and put it here. Done. Okay. So note that at this sigma equals 0, beta will be this. Alright, this will be the formula for beta at sigma equals 0. Now you just plug in the value. This is for omega, this is for this guy. Note, we have it as what? Relative permittivity is this. That means the permeability, the relative permeability is 1. And remember we said that permeability equals what? Permeability of free space times what? Relative permeability. And this one of free space is what? The one for free space is this. So also, so this times what? 1 and remains the same. Then for, that's this guy. Then for permittivity, this is the value of free space. And the one we are given in the equation for relative is what? 9. So when you multiply all this times all this, you will get exactly this answer. So now we have it. Of course, omega equals 2 pi f is given in the equation. So that will give us this. Okay. So we substitute in beta and omega to that our expression. Omega here, beta here. Of course, 100 is given in the equation. And this is simply it. Simply this is just it. Then the next thing is for average power. Average power is half. Average power density is given as what? Half of the electric, this forward traveling wave of the electric field squared divided by the intrinsic impedance. We already have this guy as 100, but we do not have the intrinsic impedance. But we can calculate for it. Okay, like I said. But this guy, sigma equal conductivity is 0. So we have everything here will be simplified or reduced to what? Just this expression. Okay, so when we do this now, yes, this guy is equal to what? This, and this guy is equal to what? This. So you just plug in the values. Okay, and when you do that, you get this as what? Intrinsic impedance. So you put that intrinsic impedance value back into this equation. Here is 100. So you do that, you get the average power as this. Okay, of course having the Z component, I mean in the Z direction. So this is just it. This is just it. I think that's all now. Okay, so please be mindful of the formulas used. Be mindful of the formulas used. Okay, so and I think that's all for this video. And yeah, so like, share, subscribe, comment, and I'll see you in the next video. Thanks for watching, and bye for now. What's this? Okay.